Hello everyone, welcome to the demonstration of QualityNexus. It is a project built on the Kaggle competition, focusing on the Google BigQuery AI. The problem statement. In the software engineering industry, release health is getting harder and harder to see. The quality signals live everywhere. Code, test, customer feedbacks, product documents, the meetings, sessions, multimedia recordings. Especially in the AI era, the coding velocity rises, and where the verification lags and test or operation actions become more reactive. So the product risk show up in the later stages. And furthermore, the data retrieval process that stitch all these diversified data sources all together, this retrieval process is really tedious and brittle, and also scattered across organizations and team members. Therefore, we really need a place or a platform to land, to link, and to reason over all of it. So we no longer need to rebuild our data pipeline every week, quarter, or year. The QualityNexus, it is built on the Google Cloud Services, especially the BigQuery. It is the multimodal quality plane that can close the bridge from the left side, the scattered data, to the right side, the insights, the reactions, the answers we need. Additionally, we build up a BigQuery assistant. It is kind of a creative step further, that we treat SQL as a core assets within the BigQuery. So it let us ask questions in natural language and then turn the questions into a chain of SQLs. Within SQL, we even invoke the AI application itself. So it will be able to reach out to the datasets, generate temporary table, and create artifacts and get answers for us. So that is really close the bridge among the end user of the AI against the raw or derived data. That is making the AI developer or AI integrator much less effort to maintain and adapt the SQLs in the very dynamic and adaptive environment. So in summary, Nexus is the platform built on Google Cloud Service, especially BigQuery, focusing on creating the bridge among the scattered data to the quality signal, including insights, forecasts, advice, and intelligent answers. The architect of the QualityNexus. Before we talk about architect, let's look into what is really the BigQuery. The Google BigQuery is the serverless SQL first data warehouse with really scalable and elastic functions. It is also based on the pay per query economics, so we have to add credit and get bills from BigQuery, and it offers a certain amount of default credit every month. So for the beginners, we don't need to be bothered about that. So beyond the classic analytics, the BigQuery also talk to the AI backend in the Google, that is the Vector's AI, the Vertex AI. It can query various of API or AI apps, including deep learning, machine learning, and various functions. Naturally, can seamlessly training the models, so we don't need to import any libraries as we do in the Python. So all the models are just one step away to reach and to use. They're ready for us. In this project, we use a Kubernetes as a dataset. The Kubernetes project activities in 2019. We use 4 major resources from the GitLab, the development and test activities, the Stack Overflow from the customer feedbacks, the Kubernetes, the product documents in its blogs, and lastly, the multimedia recordings on the YouTube. So based on all these diversified and scattered information about that particular project during the year, we want to have the insights, the forecast, the recommendations for the testing, for the development, and potentially some recommendation when we have issues. We wish to have some insightful and helpful recommendation about the fix. So these kind of requirements for the human beings, focusing on the quality signal, that is really difficult to get it efficiently and effectively, as all the data are scattered everywhere. With the Google Cloud Service, it is possible, it is feasible, and it is sustainable as well. We use Google Cloud Storage to store the process the data. Furthermore, we use the BigQuery SQL functions to further process these data, to transform them to various kind of tables, statistics tables, the embedding tables, and also the object tables for the multimodal formats. Based on this processed data, now we have a chance to use all the AI utilities and functions offered by BigQuery, supported by the Vertex AI. And here, in this project, we have used several major ones, like AI Generate, AI Forecast, Vector Search, and so on. And here, when we are invoking these apps using SQL, we don't really need to be bothered about where's the model, how many resources we need for these models. They are all handled in the backend in the Vertex AI, integrated with the BigQuery. So that is one of the major benefit of using the BigQuery. That is closing the bridge, building the bridge among us as an AI integrator towards the AI infrastructure. Having this architecture, now in this demonstration, we will see how effective it is to create the insightful quality artifact based on all the scattered resources on the left side. And I have to mention that we also use IAM, the access control modules or features offered by Google Cloud. That is so crucial for the enterprise that has strong need on the security and integrity. Before we jump into the demonstration, we would like to spend a few minutes about the assistant. Our idea is to turn the query in the natural language to a result without any coding. And the BigQuery offers the capabilities to achieve this. In the normal situation, we have to create a bunch of SQL query based on understanding about the data sets, the schemas, the catalogs, creating various tables, and also maybe asking around for good experience from other people. Then we will be able to generate result. But actually, these process can be automated and can be even empowered by AI itself. So our idea is to use the BigQuery AI generate application to transform the natural language into an SQL. The context is the query itself and the schema or structure of the data sets, the schema of the table, and furthermore, the earlier historical successful queries. By combining these essential resources, we can create a list of SQL, and these SQL will create temporary table. And even further, within these SQL, they will invoke the AI application itself and circulate back again. So this becomes an iterative loop and will get us finally reach to the destination, the result we need. We make an initial pilot on this, a prototype, and it proved to be successful. Even though there are a lot of enhancements we can do that, but it is technically feasible. And it's really helpful, and it's showing the power of the BigQuery that maybe we no longer need to create SQL by ourselves. And it can be generated intuitively, automatically, and they can be managed. So SQL itself will become yet another data to be managed. We will give a short demonstration about the outcome of this. I believe that is probably one of the future steps we can take together with the BigQuery to make it more meaningful, more beneficial for many end users, but not only the AI developers. So now let's come to the demo. We are talking about the left side, the scattered data, and toward the right side, the business insights or technical details. So here, this is the forecast. We generate the GitHub metrics, and then using the machine learning ARIMA models offered by BigQuery and also the AI forecast, these kind of simple forecast can be easily done. The result is decently good, but I think it still need to be fine-tuned in the future. Like we haven't really trained the model well, and also the historical data is not good, sufficient. So the forecast is not as accurate as we want, but it is working. Generative. Again, we use the metrics in the GitHub, and plus the events and the feedbacks in the Stack Overflow from the customer. And here we can generate the insights of every quarter based on the statistics and events or customer feedbacks. And based on the quarterly insights, we can also furthermore generate a yearly summary. And the yearly summary is not only based on the statistic data, but also the content, the sentimental information from the customer. Similarly, instead of making summarization, we can use RAG technology to generate something new. In this case, we try to provide a troubleshooting guide for a particular issue. So we have a question about some issues on some volumes in the Kubernetes, and then we want to have insights about what are the changes in these Kubernetes versions, what are the potential causes, and how we can diagnose and fix that. And actually, these knowledges are scattered also everywhere, like in the GitHub issue events, the product in the Kubernetes, maybe even in the team meetings and so on. So here we take two of the resources in text and in PDF, and we use the object table to do the vector search, and it turns out the troubleshooting guide can be easily and quickly generated. It is quite accurate and relevant to the context. Similar to the troubleshooting guide, we also try to build a test case advisor. Since software are changing and accelerated by the AI, and test case has to adapt, and even more frequently. So we do have insights about what are the most crucial test case to execute, and that can be based on the GitHub pull request event, the product release note, and also the team recording. So in this case, we are adding the multimedia as another multimodal resource. And based on that, when we ask what are the focused testing for a certain feature, we will be able to get the list of areas, the reasoning of it, and also the proposed test cases per area. And this is quite effective, and it's very relevant and can be a really efficient guidance for the test team to be able to reflect what is really happening on the upstream and then plan their activity in the downstream. So we had talked about the multimodal for the RAG and for the like troubleshooting and test case generation. Here again we are using multimodal, but for the summarization. A dashboard is quite commonly used in the product operation, and people want to see what is happening statistic wise. And following the Google DORA paper last year, it is believed that there are 4 or 5 KPI. It is so crucial for the product quality or the product operation measurement. So the QualityNexus can transform the GitHub event to various dashboard on demand, and this dashboard will be turned into images and saved in the object table, and finally generate executive insights, not only based on the text and statistics, but on the image itself. It turns out to be really effective and intuitive in this case. So people really don't need to look into the bar chart and line charts, but they will get a very good inspiration from all the generated report. Finally, let's talk about this BigQuery assistant. We have seen all the use case demonstration earlier, and they are all being built by the tailored SQLs. and it can be enhanced. Like maybe we don't need to build SQL by ourselves. So in this case, with the BigQuery assistant, we ask natural language questions, summarizing the KPIs, find top 10 questions, and these kind of human questions can be processed, and there will be SQL generated using the BigQuery. And this SQL will further query the application or AI application and generate the needed summary on this. That is reducing tremendous effort on the AI developer and integrators to build up these SQLs. That is, as we say, close the gap between the end user and the AI services offered by Google Cloud. However, the quality of these SQLs and also the needed context for generating this SQL remain to be assessed. But here we are demonstrating a potential and a feasibility. So that's all for this demonstration. And before we close, I want to share some reflections. To be honest, I'm quite new in this Google query, BigQuery, and Google Cloud Services. During the journey in this hackathon, I can reflect that this Google Cloud Console, including BigQuery itself, is really easy to learn. And it has very user-friendly UI. We have various of documents. And furthermore, this BigQuery is natively integrated with cloud storage. However, I feel some challenges when I use it. First of all, there are so many different features in the console. And many of the features or configuration need manual integration, especially the principals, the IAMs, and the cloud storage. I believe that some wizard shortcuts or maybe some automation assistant could help us to speed up the manual integration work. Additionally, it will be good to have some comprehensive end-to-end production level project as an example that can integrate various of features within the Google Cloud Console altogether, like the measurements, the principles, and so on. And going forward, I see a promising future of BigQuery, and I even plan to adopt or try this BigQuery in our company DevOps environment. First of all, we believe that this coding buddy for SQL will be really effective. We have in our company, we have a lot of legacy DevOps assets like Jira, Jenkins, GitHub, and I hope if BigQuery can have such kind of plug-in and connector, it will be really attractive for us to adopt BigQuery if these kind of legacy assets can be integrated. With that, hopefully we can migrate and transform our legacy data to the Google Cloud Service, and that will really resolve the AI transformation bottleneck.